Section 6.6, problem number 2, solve the following logarithmic equation. We've got a log on the left, a log on the right, and we have a constant term. Since we've got that constant term, we need to group all of our logs to the left. This is a minus sign right here, so when we move that, it's going to need to change. Let's look at the actual working of it. We started out, this is negative, we move it, it becomes positive. The 3 remains. This time, since it's a plus, we use the rules of logarithm to condense. We were adding, so when we bring them back together, we multiply. Remember, those rules are the reverse of the exponential rules. So we have condensed it to a single log. The next step is to change it from logarithmic to exponential. The base is 5, the exponent 3, and this whole 2 binomials multiplied together right here represents the end there. Now, we would clean this up by foiling it. First, outer and inner combine to give you the 10x, and last. But to be able to proceed on with it, we need it to be set equal to 0. We're going to move the 125 to the left. It becomes negative. Negative 75 and negative 125 give us the negative 200. Now, let's see if we can factor this. Does 200 have factors that have a difference of 10? Yes, they're 20 and 10. The larger one needs to have the negative sign, the smaller one, the plus sign. You can foil it back together to double check if you feel like you need it. Set each of those factors equal to 0 and solve. Well, we get 20, we get negative 10. Okay, that's great. But remember, the domain of logarithms is limited. You cannot take the logarithm of 0 or a negative number. So you check to see if either of these produces a negative that would be inside of the logarithm. So let's check the 20 first. And we had the 20 plus the 15, which was 35, and the 20 minus 5, which is 15. Both of those numbers are positive. That's good. But when we check the negative 10 plus 15 is 5. Well, that's okay. But when you check it in the other one, negative 10 minus 5 is negative 15. And we can't get the logarithm of negative 15. Therefore, we cannot use negative 10 as a solution. It is not contained in the domain of the function. So the only solution is the 20. I hope you understand this, and I hope you see the importance of checking those solutions.